We start with a vector W and a vector V. Vectors have magnitude, magnitude W, and magnitude of V, and there's some angle theta in between them, which is not specified. All we know is the components of W and the components of V. We can use these vectors as a basis for constructing a parallelogram. We ask what's the area of this parallelogram. Now let's just look at a slightly smaller parallelogram I've sketched over here. I claim that I can cut this parallelogram along a line that goes through this vertex and comes to a perpendicular at this point in such a way that if I take the piece that I've cut here and move it over here, it's going to form a square, so that having made the cut and pasted everything back together in the indicated manner, we get not a square but a rectangle. Now, the area of that rectangle is equal to whatever the length of this side is multiplied by whatever the length of this side is. If we apply that idea to this parallelogram, we see that we can construct an altitude here, a line from the vertex at a right angle to one of the sides, and that would correspond to this line here, which has the same length as this line, so that this line here multiplied, the length of this line multiplied by the length of the W vector is going to give us the area of the parallelogram. The only question is, what is the length of this line here? Well, that length, if you look at this right triangle, is very clearly magnitude of V sine theta. Now, if we recall the cross product, we know that the magnitude of the cross product of V and W is magnitude of V times magnitude of W times sine theta, and actually I need another set of absolute value signs here because the sine of theta could be positive or negative. So that we can use this idea to obtain an expression for magnitude of V sine theta, which when multiplied by W gives us the area